So that's from the word trigonometry. Tri, first three letters that means a three, and then a gon, like it's an angle. Then metry is the measurement. So we're talking about the measurement of three angles. Right, so that is what we're interested in understanding in trigonometry. And the first one we should understand is a right angled triangle. Now, because this is a triangle, you expect the sum of interior angles to be equal to 180 degrees. So if you add all these angles which are inside, you should get 180. Since this is a right angle triangle, this is going to be 90 degrees here, right? Okay. Now, I'm going to get any of these. If I get any of these angles apart from this 90 here, I get any other. Let me say I get this angle here. This is going to be my reference points. Now when you are labeling these, let's say this is A, you've got B, and then C. So angles are always given a capital letter. That means this is going to be angle A, this is going to be angle B, this is going to be angle C. Now the sides, this side where this angle looks like this is going to be given a small letter A. Okay, it is going to be given a small letter A. Then this side where this one points is going to be given a small letter C. Then this side where this other one points is going to be given a small letter B. We're good? We're good? Alright, so from here, I want to introduce you back to this thing. You need to know it by heart, SOHCAHTOA. So depending with the angle that I'm talking about, depending with the angle that I'm talking about, if I'm talking about this angle here, okay, you should know the sides. So if my reference is this angle here, then this side where this angle is next to is called the adjacent. This is going to be the adjacent. And then this angle is pointing, you can see the opposite. So this side is going to be the opposite. And then wherever this 90 degrees points, where the 90 degrees points like that, this is the hypotenuse. Now, if my reference point is this other angle, if my reference point is this angle here, then this side is going to be the opposite side. And then this side, they are still next to be the adjacent. Adjacent means next. And then this side, that is still where the 90 points, that will still be the hypotenuse. Okay, Mark, is this okay?
Yes, it's okay.
Alright. So from the SOHCAHTOA we can see that sin. Now in this case, if we're talking about this angle, then it's going to be sin A. That means the angle A. Please, you use a capital letter for angles. That is going to be equal to opposite. What is the opposite? We can see the opposite. Now, this adjacent I wrote is when you're talking about this angle. When you're referring to this other angle, this is not the opposite. Okay, this is not the adjacent, it's the opposite. When you're talking about the angle A opposite, we can see that is going to be small letter A, and then you have got H, that's the hypotenuse, over hypotenuse, and the hypotenuse is C. So this becomes the formula. Alright?
So
Yes.
you mean calculator C.
So alright, so this is supposed to be a small letter C since it's a side. And then if you go to cos of the same angle A, is going to be adjacent over hypotenuse. So in this case, if you look at the angle A, the adjacent is here. Okay, the hypotenuse is still C. And then if you go to tan of the same angle A is going to be equal to opposite, which is this one A, now over adjacent. Okay, over adjacent, now the adjacent is a B. So this is how it gets to become, right? Now, one important thing that you need to understand when you're talking about these, they're going to make sense. You need to understand what we call special angles, because they'll give you some angles. You need to understand special angles. And for the special angles, we have got 30 degrees. We'll start with 30 degrees. So if you want to understand this special angle, 30 degrees, you are going to use a type of triangle which we call uh, an equilateral triangle, and it goes together with the 60 degrees. Excuse me. So this thing you are able to see here, all the sides are the same. Okay, this triangle you are able to see here, all the sides are the same. Meaning that this side and this side and this side, they are all equal. And so since the sides are all equal, meaning that even the angles inside, they are also going to be what? They're also going to be equal. Now you know that a triangle adds up to 180. So since the angles are the same, so divide 180 by 3, because we've got 3 sides, mean that each angle is 60 degrees. Each angle is 60 degrees. Even this one is going to be 60 degrees. But for this one which is on top, the 60, what I'm going to do is I'm going to get I'm going to cut it on the middle again. Okay, I'm going to cut it on the middle like that. Meaning that this will now be 30 degrees. This will also be 30 degrees, right? You get that?
Yes.
And then this one here is going to be 90. Now, since all the sides are the same, this you consider like each side to be 2 centimeters or 2 units. So this is going to be 2. This is going to be 2. It's also going to be 2. Now, since I've cut on the mid, you can see I've cut here, meaning that this is going to be 1. This is also going to be 1. We've cut that angle on the middle. So that is what I'm going to do. This is going to be 1. This is going to be 1. Then from here, I'm going to remove one side. I'm going to remove this side. And then I've remained with a right angled triangle. Okay, there is a right angled triangle. Now, to find this side, we know from our Pythagoras theorem, if you have got something like this is a triangle. This is, can we say this is x? Let me say this is x, this is y, and this is r. A 90 degrees is here. So when you want to find this longest side, r, you are going to square it, and that is going to be equal to x squared and also y squared. If you want to find this any one of these short sides, like x squared, it is going to be the longest side, r, you square it, but subtract. You subtract y squared. Same if you want to find y squared, to be the longest side squared minus x squared. So here we have got this side and it is a short side. So if we want to find this side, what we are going to do, let me call it as y. So y squared is going to be, we get the longest side. The longest side is always where the 90 degrees is pointing. Okay, this one, the hypotenuse. So I'm going to get that, I square it, minus, I get this one, I also square it. So this will give us y squared being equal to 2 squared is a 4, 1 squared is a 1. So that is just 4 minus 1, which is a 3. Now I want to remain with a y, so y is going to be equal to square root of 3. We are going to square root both sides like this. Okay, this square and this square root cancel, so just remain with a y. And then this side we're going to have square root of 3. So meaning that y is the square root of 3. I'm going to put square root of 3 there. Okay, like this. Now from here, if you are talking about sin, let's start with the sin of 60 degrees. Remember we said sin is what? Always remember the SOHCAHTOA there. Sin is given by opposite. So if 60 is here, we're talking about sin of 60. Opposite is the square root of 3 over hypotenuse. Hypotenuse is 2. And then we talk of cos of 60. Cosine of 60 degrees is going to be, cos, remember, is adjacent of hypotenuse. Adjacent to 60 is 1. The hypotenuse is a 2. And then you have got tangent of 60 degrees, and tan is given by opposite over adjacent. So that's square root of 3 over 1, which is just square root of 3. And then when we go to 30 degrees, sine of 30 degrees is going to be equal to, what you do is, if 30 is here, and you know that sine is given by opposite over hypotenuse. So opposite is this side, hypotenuse is this side. Okay, so that is going to be, opposite is 1, hypotenuse is 2. And then you have got cosine of 30 degrees. Now cosine is given by adjacent, so to 30 the adjacent is this one, the hypotenuse is this one. So that is going to be square root of 3 over 2. And then tan of 30 degrees is going to be, tan is given by opposite over adjacent. So that is how we're going to get, so that is 1 over square root of 3. Okay, is this okay?
It's okay.
So what I want you to master in your heart is that cos of 60 is always half. Half is the same as 0.5, and the sin of 30 is always half. I need you to have this in your mind because these come in the exam, like especially sin of 30 to come in your exam, especially paper 1 where you don't use a calculator. So apart from this, let me just show you 45. Now 45 degrees, we use what we call an isosceles triangle. An isosceles triangle is a triangle that has got two sides the same. Okay, so for this triangle, this side and this side they are the same, and this is the 90 degrees. So meaning, since these two sides are the same, even these two angles are going to be the same. One is 45, even the other one is 45. Now for this kind of triangle, we're going to take this side as 1 unit, also this side as 1 unit. Now you find the hypotenuse. To find the hypotenuse, let's call it r. You say r squared is going to be 1 squared plus 1 squared. So that gives you r squared being equal to 2. Square root both sides. Find that this square and this cancel. So r is going to be equal to square root of 2. So this is going to give us the square root of 2. Now you can find what is sin 45. So sin 45 is going to give you, you look at the angle 45 is here. Sin, remember, is opposite over hypotenuse. So you can see that is 1 over square root of 2. And then you go to cos 45, which is given by adjacent. Okay, this is the 45 adjacent over hypotenuse. So that is 1 again over square root of 2. And then you have got also tan 45. Now tan is given by opposite over adjacent. It is 1 over 1, which is just 1. So this is for 45. These are special angles. All right, are we good? Are we good with this?
Yes, okay.
All right. Now, after understanding this, we should now be able to understand how to find the missing angle or the missing side. How to find the missing angle or the missing side using the same things that we've said here. Okay, let's say we've been given a triangle like this. Okay, so here is the triangle that we've been given. This is 90 degrees. And let's say they've given us this is 30 degrees. And then they've given us that this is let's say this is a 2. And then the question is find x and y. Okay, find x and y. So to be able to find x and y, we are going to use the same soccer tour that we've talked about. So if you look at sin, the angle that you've been given is what? Is 30 degrees. So sin 30 is given by what? Opposite over hypotenuse, right?
Yeah, so it's it 8/2.
Yes, good. So that will be x over 2. Now remember I told you you need to know what sin 30 is. What is sin 30?
Okay. Then you have then you can use cos 30 centimeters.
What is sin 30? So from what I've said you need to know sin 30 is always 1 over 2. So where there is sin 30, I'm going to put 1 over 2. And that is equal to x over 2. Okay? From here now,
One over two.
from here we cross multiply. 2 times x, that is going to be 2x. Then 1 times 2, that is going to be 2. Divide both sides by 2 to remain with x. So x is going to be equal to 1. Meaning that this side is 1. Okay? So we can easily find y using the Pythagoras theorem. We know that y is a shorter side squared is going to be equal to, you look at the longer side, that is 2, you square it, then minus, you look at the shorter side, which is 1, you square it, right? Which also gives you y squared being equal to 2 squared is a 4 minus 1, which is a 3. So if you want to remain with y, square root both sides. So that means y is the square root of 3. So this is square root of 3 here. That's the answer.
How did you find 3?
2 squared is a 4. 1 squared is a 1. 4 minus 1 is a 3.
So you mean that you have to do this 2 times 2 times 2 to
Yes.
the power 2.
Yes, 2 to the power 2 is
So it's supposed to be 4
going to,
minus 1. It's going to be 3x
yes.
minus 9.
All right. Now if you didn't want to use this formula, if you didn't want to use this formula, what you do is you can also use the sin square. Remember sin square also gave us 1 1 over 2, right? I mean cos square gave us 1 over 2. Okay? So now we can't basically even use that. So that is the procedure that we can do, because another way we can do is we'll look at cos. So I'm going to say cos, the angle that we have here is 30. That is given by opposite. Okay, it's given by opposite. I mean cos is given by adjacent. Remember, I saw katoa. Then by adjacent, the adjacent side is this one, which is the y over
1/2.
okay, over 2. Now we said what cos 30 is equal to what? What did we say about cos 30? It's equal to what?
1/2.
No, 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 no.
It's
Cos 30.
uh, square root 3.
Square root of 3 over 2.
2.
And this is going to be equal to y
1.
over 2. Okay? Since these numbers which are down, they are the same, meaning that even what is on top, y is going to be equal to square root of 3. You can also use this. So we've seen that the answer is the same. Is that okay?
Yes, it's okay.
Okay, so that is how you get to find the missing side. The missing side. You can also determine the missing angle, but before then, also need to understand, because at times are going to be given this. Okay, let's say this is what you've been given as A, B, C, D. Right, so okay, so this is what you've been given, A, B, C, D. Now let's say uh, what can I,
Very difficult.
this is the 90 degrees at this point. Okay, so that's the 90 degrees at that point. Huh. Now let's say they've said, and we have this one, let's say we can say this is A1, this is going to be A2. So we can determine this side. Now let's say the question is saying find sine A, C, D. That's the question, find sine A, C, D. So I want to find where is ACD. ACD is this angle that you're able to see here. Okay, that's the angle that you can see there. Now the first thing you need to know is you need to find the hypotenuse here. Alright, so that will give you, let's say it is R. R is going to be 1 squared plus 2 squared. So R is going to be 1 plus 4. Then R is going to, this is also R squared. R squared is going to be 5. So square root both sides, meaning that R is equal to square root of 5. So that's the answer there, square root of 5. Now, if you are looking for this, the sign, when you have got an angle like this, you need to know that the sine of this angle is the same as the sine of this angle. Do you understand that?
Yes, I understand.
For example, if you have a line like this, okay, if this is 30 degrees, what is going to be this? Can you find this angle? What will be this? How can we find this one?
Okay, let's be 1/2.
No, so what you do is, since this is a straight line here, this is a straight line, meaning that this angle and this angle, when you add them, they are going to give you 180. So you say 30 plus x is equal to 180. So you take 30 the other side, so x is going to be 180 minus 30. X is going to be 150 degrees. So this is 150 degrees. So we know that what is sin 30? What is sin 30?
It's 150.
Sin 30 is 1 over 2. So since we know that sin 30 is 1 over 2, meaning that sin of this angle here, sin of 150, is also going to be 1 over 2. So this is what you need to know. Okay? So for this one, we want to find sin ACD. We want to find the sine of this angle. Meaning that the first thing that we're going to find is the sine of this angle that is inside. Right? So what angle is this? The angle inside is ACB. Okay, that's how we get to give angles. That's ACB. So we're going to find sin ACB. And how do we find sin ACB? Sin ACB we know is given, sin is given by opposite over hypotenuse. Now the opposite in this case, if you look at this angle, this is ACB. Opposite is 1, hypotenuse is square root of 5. So that will be 1 over square root of 5. Meaning that, okay, sin, the one they've asked us to find, sin ACD, the sine of this angle which is here, is just going to be the same as this one. So sin ACD is the same as sin ACB. Okay, and we've determined that is 1 over square root of 5. Are we good? Are we okay, Mark?
Yes, I am.
All right. So what of finding now? We found question A. What of B? We want to find cos ACD. Cos ACD. How can you find it? So again, cos A C D. First, we need to find cos A C B. All right. So that is going to be cos A C B is going to be. But how do you find cos? Cos is adjacent over hypotenuse.
I have a question.
Yes.
Um, After cos ACT, so you have to change it to APC or ACP.
Yes. First, you need always to find the one together with the triangle.
Okay, okay, I understand.
Okay. So cos ACB is going to be equal to adjacent. You can see that is 2. Hypotenuse, that is the square root of 5. Okay. Now, if you want to find cos ACD, now cos ACD is always negative cos ACB. So if you have got an angle like this one and this one, let's say this is 30, this is 150. So we are saying cos 30 is the same as negative cos 150. If you get this 150, you put a negative, is going to be the same as cos of this one. That's why we've said this. So therefore cos ACD, the one the vastus is going to be negative. What is cos ACB? We found this one. That is 2 over square root of 5. So this is how you get to answer this one. Are we okay?
Yes, I'm good.
Alright. So we are going to see a lot of interesting questions on this. Let me just talk about. So say you have another triangle which you've been given. This is, let's say, A, BC. This is 90 degrees. Okay. And then the question says if cos BAC, okay, if cos BAC is equal to 2 over 3, find sin uh, BCA. Right, we are going to see such questions. Find sin BCA. Now you can even see the triangle here, but they've given us that cos BAC. If you look at BAC, the thing that is on the middle here means that's the angle. So it is what? Is the angle A. Okay, so there is angle A. Now they've told us it is equal to what? 2 over 3. Cos of an angle is equal to 2 over 3. How do you find cos? Cos is given by opposite of, adjacent over hypotenuse. Meaning that this side is adjacent, this side is hypotenuse. Okay, meaning that to this angle A, the 2 is adjacent, 3 is hypotenuse. Is this okay?
Yes, it's okay.
And then now we need to find this side. Okay, let's call it, since this is A, this is going to be small a. So let's find small a. Small a squared is going to be, we get the hypotenuse, 3 squared minus, we get the 2 squared. So a squared is going to be 3 squared, that's 9, minus 2 squared, that is a 4. So a squared is going to be 9 minus 4, that is a what? That is a 5. Then square root both sides, meaning that this side is going to be square root of 5. Okay, it's going to be square root of 5. And now the question is saying find sin BCA, meaning that the angle of our interest is C, because that's the one on the middle. And you know that sin is given by opposite. Okay, the opposite is this side, which is 2, over hypotenuse, which is 3. Imagine maybe they also said find cos BCA. Cos BCA would become cos is given by adjacent, which is square root of 5, over hypotenuse, which is a 3. So this would have been it. That is how we would have worked them out. Are we good?
Yes.
Okay, this same question, let's say they also said uh, find angle C. You want to find angle C. What angle is this? So there are many ways, just like we've said. If we use sin, we're going to see sin the angle C. We know sin is given by opposite. Opposite, that's 2, over hypotenuse, which is a 3. Okay, but you don't want to have a sin here, so you more like take sin the other side, because you want to find the angle C itself. So C is going to be, when sin goes the other side, it becomes sin inverse, okay, with a power 1 on top, and then you're going to write 2 over 3 like this. So this is going to be the angle. If you have got a calculator, we're going to punch this on a calculator, but you don't use a calculator in the exam, so you just leave it here. Okay,
So we are to have to use calculator, just have to stuff like that.
yes, you leave there, unless paper 2 you are going to punch on the calculator, and for paper 2 we are going to do those in the next session.